Sucks for them. All right, here we go. So we're going to start solving. We're going to start using logarithms. So we've gone through their properties. We've gone through how we can condense them, expand them. We've gone through a couple of those examples. Now let's talk about how we can use them to actually solve for x, because that is their most efficient purpose. That's why we have, not why we have them, but it is what we use them for it from time to time. Solving for exponents, solving for variables that are in the exponential level. So this is one said case that we would want to do that. This is one of the more complicated examples, so stay with me if you can. What do you notice about this right off the bat? 1, 2, 3 terms, right? Variables involved in 2 of the 3 terms, so we would call this a trinomial. Okay, now when you look at this, you see that there's a squared, but it's really like a 2x, and you see that this is e to the x, and you want to say to yourself, is this one of those quadratic equations? Is this quadratic? And the answer is yes, it is. Now here's why. This e to the 2x is e to the 2 times x. Everybody agree with that? That's what that 2x is 2 times x. So really I have a product in the exponent. So where could that product have come from? You don't have to write this down just yet, but play along, okay? E to the 2 times x, now watch, that's the same as e to the x times 2. Multiplication is commutative. And if I'm taking the product of 2 exponents, where could that have come from? Like when I add exponents, it's because I was multiplying 2 exponential terms, right? X cubed times x squared is x to the 5th. So why would I have multiplied exponents? Because of powers of powers. That's one of our properties of exponents. When you have an exponent of an exponent, or a power for a power, we multiply those together. So, long story short, e to the 2x is the same thing as this. So now, if I make that substitution, this is really e to the x squared minus 4 e to the x plus 3 equals 0. So this is, in fact, a quadratic trinomial. Excuse me. I have something squared, something, meaning this e to the x is squared. In this term, it's not. And then I have a constant. So this is a quadratic equation, set equal to 0. We can use a quadratic formula. We can try to factor it. But when you're looking at this and you're like, oh my gosh, I don't know what to do with this. Remember what I've been saying for some of these more complicated looking equations. This concept of substitution, right? If you're uncomfortable factoring what this might look like, at least we can identify that I have something squared, I have that same thing here. And I recognize that I'm going to be solving for that. And if that's what I'm going to need to be solving for, then I'm just going to call it A. So brief little interlude here, okay? All right, stop, that's why I chose red. We're going to stop. We're going to say reset. I'm not going to talk about e to the x right now. I'm going to say e to the x is A. And if I do that, it's a squared minus 4a plus 3 equals 0. That I am so much more confident in my ability to factor. Right? Now, the further you get into math, the further you go along, you are going to have to be able to factor things like this and understand what you're doing. But for now, let's practice this concept, this skill. So now it's a quadratic trinomial that I can factor, hopefully, fairly easily. I'm sure you're all confident and able to do that. And I have my product of linear factors set equal to 0. So that must mean that a minus 3 equals 0, and a minus 1 equals 0. So a equals 3 and a equals 1. Still with me?
Mm-hmm.
You're like, oh, this is nice, like a warm blanket. So comfortable doing this. I'm so good at this. Okay? But let's not forget what a is. We're not solving for a, we're solving for x. And a is e to the x. So I have to come back to reality. Okay? Snap back to reality. Oh, there goes gravity. Oh, there goes gravity. Choked. It's so sad that he goes. You know, that's Eminem, in case you guys didn't know that. Okay, you're welcome for that. You're welcome for that. Okay, so we're back to what we're supposed to be doing here. How do I solve for x? How do I get that exponent out of that level? With logarithms. Now, very specifically, we want to use a logarithm that's going to isolate that x after it's moved down. And the way that we do that is by choosing a logarithm with a base that is the base of our exponent. In other words, in this case, because you're going to be doing a ton of stuff with e, you take the natural log of an equation that involves e. Why do we take the natural log? Because natural log is log base e. Right? Now when I do that, technically I shouldn't have wrote that. It should just look like this on the next level. You're taking the natural log and the x is coming down. Okay? And the natural log of e, showed you before, is 1. So we get, I'm sorry, was anybody going to call me out on this? You can't just do it to one side, right? Whatever you do to one side, you have to do the other. You're shaking your head. You're like, yes, you idiot. You were supposed to do that before. Can't believe you're, I'm not calling you an idiot. I'm saying you're calling me an idiot. Right? Okay. It's a bad word. We shouldn't use the word idiot. But dunce. That doesn't hurt as much. Okay? So, when I take the natural log of the left side, I have to take the natural log of the right side. The natural log of e is 1, so I have x times 1, which is x. X equals the natural log of 3, and typically speaking, we just leave it like that. Because that's not going to have a value that, it's a decimal value here. Okay? The same thing will happen over here. I'll take the natural log, let me separate this. I'll take the natural log of the left side. I'll take the natural log over here. The natural log of e is 1, so I have x times 1, which is x. And the natural log of 1 is, good, 0. The log of 1 is always 0. Natural log, common log, log base bagillion. Okay, it doesn't matter. The log of 1 is 0. So I have this statement, I have this statement as my solution. Alright? So, to reset, in a problem like this, e to the 2x is really e to the 2 times x, which is really e to the x squared. So it's a quadratic. I have something squared, something not squared. Okay? So I can say that thing, we were doing this with sine x's and cosine x's before. That thing that I know I need to solve for before I solve for x, I'm going to call that a, or u, or anything, right? And then any variable I want. And then I solve until I get that. I resubstitute the value of what I said it was. E to the x was a, so I put e to the x back in. I take the natural log here because that has a base of e. If this was a 4, if it was 4 to the x, I would take log base 4 because that's going to cancel that 4 out. Okay? And then when I get to here, natural log of e is 1. I'm left with just x, which was the original exponent, equal to natural log of 3. And 0.